All right, if you were having trouble on these, you're not alone, but it is something that we're going to be doing over and over and over and over again. So I thought I would show you my strategy for doing this. If you have your own way, that's great. But the goal here is to write an expression, meaning something with a variable in it, for a tile pattern. Now, the first step that I always think about is, and we want x to stand for the figure number, so that we could use the expression to find out how many tiles there would be for any figure number, so figure x. And that's helpful because if I ask you to find figure 100, you don't want to draw this over and over and over again. So the first step is to figure out what is the pattern, like how is it growing? And the way I like to think about it, you don't have to use a table, is to have the figure number is our x, and then our y is going to be the number of tiles. So if you count them up, figure 1 has 1, 2, 3, 4, 5. So figure 1 is 5. Figure 2, 1, 2, 3, 4, 5, 6, 7, 8. Figure 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, and what I can see is that this is growing by 3 and by 3. So this is growing at a constant rate. So that means that it is going to be linear. And if it's linear, if it's growing at a constant rate, it's going to fit this pattern. So I just draw this. Y equals some number times x, being the figure number, plus some number. And then, I mean, there's other ways to do it, but one way is just trial and error. And so just start with, okay, what if the pattern was y equals 1x plus something? So then I go over and look at figure 1 and say, if that was the rule, then what would have to be the thing that we're adding on? So figure number 1, we plug in 1 for x. Remember, this is the figure number. So this would be 1 times 1, and it would have to be plus 4. Okay, so that could be the rule, but the question is, does that rule work for figure number 2? And so to test that, we would go y equals 1 times 2 plus 4, plugging in x for figure 2, and that gives me 6. But what I was looking for was 8. So that tells me that rule does not work. So we try another one. Next number up is 2. Well, if it's going to work for figure 1, then it's got to be 2 times 1. We would have to add 3 on there. Now, does that work for figure 2? Y equals 2 times 2 plus 3 equals 7. No, it doesn't work. So we get rid of that, and we try 3. Well, if it's going to work for figure 1, then it's got to be 3x plus 2, and we're going to test y equals 3 times, here's our x of 2, plus 3, plus 2. I was confused there because I was expecting this to work, equals 8. Yes, it works. Okay, does it work for figure 3? Y equals 3 times 3 plus 2 equals 11. Yes, it works. And so our rule, therefore, is right here, y equals 3x plus 2. So that's a strategy that I use if I'm having trouble seeing it right away. And the key is figuring out how is it growing. If it's growing at a constant rate, meaning you're adding the same amount each time, then this strategy will work. If it's growing at something other than a constant rate, it gets a little bit more complicated, and we'll tackle that later.